Okay, last question, and we'll get stuck into this one now. So it's question 4, and it's about hydrogen peroxide. When it's exposed to sunlight, it breaks down into water and oxygen. Calculate the mass of oxygen produced when this amount of this much molar hydrogen peroxide decomposes. So let's go through again. It's calculating certain amounts. We're probably going to need to use stoichiometry. So one is always an equation. Hydrogen peroxide, if you don't know what it is, Google it, okay? But I know what it is, so it's H2O2 is hydrogen peroxide. This is decomposing. So it's forming water, which is given to you in the question, H2O, and oxygen, O2, because oxygen gas is O2, and you should know that. Okay, this is unbalanced. Clearly, we need to put a 2 here, okay, because we've only got one oxygen here. So that means we only have an odd number of oxygens on this side, so we want to make it even, because we can only go in even numbers. Just a little bit of a maths trick for you. That means we need 2 of these, which means we have a balanced reaction now. So we have an equation that is balanced. Important start. Question 2 is mole. Find out the mole of what we can find out. Oh, before I did that, I should have written down what we have. I've got volume and concentration of hydrogen peroxide, 250 ml, and 0.5 molar hydrogen peroxide. And I want to find out mass of oxygen, unknown grams. Mole. I can find out this because I have volume and concentration. So number of mole equals C times V. So that equals 0.5 times 0.25. Remember, this one has to be in litres, so I have to change it to litres. Work that out on my calculator. 0.5 times 0.25 is 0.125 mole. Okay, excuse me. Go let the dog out. Alright, now where was I? That's right, I've done part 2. Step 2, I found the number of mole of H2O2, hydrogen peroxide. Now, step 3 is ratio again. Okay, always step 1, equation, step 2, mole of what you can find out, step 3, ratio. It's number of mole of what I know over its coefficient. Coefficient of hydrogen peroxide in this equation is 2. Equals number of mole of what I don't know, which is oxygen, O2, divided by 1. This means, okay, that the number of hydrogen peroxide over 2 equals number of mole of that over 1. So that if I just substitute this in, 0.125 divided by 2 will equal my number of mole of O2, because divided by 1 just stays the same. So that means 0.0675, I think that's 675, 25, I can't even count, equals my number of mole of O2. Okay, this is a different ratio to all the other ones. All the other ones were 1 to 1 or 2 to 2. You can see here, because this is different, I've had to substitute in what this number of mole is and do an equation here. So I get my number of mole of oxygen is 0.0625. Okay, that's mole. Now I can do step 4. Step 4 involves doing what the question asked me to. Do it. Question asked me for grams of oxygen. So I know mass equals number of moles times molar mass. So that equals 0.0625, which is my number of moles of oxygen, okay, multiplied by the molar mass of oxygen, which, because it's oxygen 2, because it's a gas, is 32. I multiply this by 32, is exactly 2 grams, which is pretty crazy. Okay, so therefore I get 2 grams of oxygen gas produced. And again, Exactly the same steps. Equation, mole, ratio, do the question. Every single time we're doing the same steps. And I'm writing them out, as in 1, 2, 3, 4. Each time I'm writing out what I have, number of moles of hydrogen peroxide, number of moles of oxygen, so I know exactly where it is. I don't take any shortcuts, so you should not take any shortcuts either. Enjoy these and have a go at all those questions in the textbook, and I'll be back with another podcast about titrations, trying to explain to you what a titration is.